In this video, I'll show you how to solve basic trig equations. So let's start off with a sine of x is greater than 0 on the interval of 0 is less than or equal to x is less than 2 pi. So we move everything to one side, which is already done. So now we have to change the inequality sign to an equal sign. So sine of x is equal to 0. And this happens at x is equal to 0, pi, and also at 2 pi. So these are our boundary points. Now we can create our boundary inequality equation. So this is our note. We're looking for positive for this let me just write that under there. So yeah. So okay, now we can label. We have interval of 0 to pi, and we also have interval of pi to 2 pi. So we can label pi right here, and then those are our two intervals. And now we're gonna test. So we're gonna test our interval 1. We're gonna test the value of x is equal to pi over 2. And then if you plug this in, if you do sine of pi over 2, you get this is positive. It's greater than 0. So that means we'll write a positive over this first interval. Now for our second interval, we do x is equal to 3 pi over 2, which is the easy value that we know. And then we do sine of 3 pi over 2. And that's going to be negative. So we write a negative sign over that interval. So now over these intervals, we have this interval will be negative and that will be positive. And the inequality, we want the positive solution. So that means that this is going to be our solution. And remember that it's exclusive. So that means our solution will be written as 0 to pi, and then we can write open circles to indicate that those parts are exclusive, and then this is gonna be our answer. Now let's do another question. Let's say that we have 9. For question 9, we have cosine of x is going to be less than or equal to 0, and this is going to be on the interval of 0 is less than or equal to x is less than 2 pi. Now we want one side isolated, but it's already isolated, so now we just solve the inequality. Now we have cosine of x is equal to 0, and then this happens at x is equal to pi over 2, and also at 3 pi over 2. So these are going to be our boundary points, and now we're going to draw our little number line right here. We can label pi over 2 and also 3 pi over 2, basically like right there. And then now we can write our intervals down here just to keep it clear what our things are. We have pi over 2 to 3 pi over 2, and then we have 3 pi over 2 to 2 pi. And now we can test these intervals, and we can write for our first interval, we have we can test the easy value of x is equal to pi over 4. And then when you test that, that means that cosine pi over 4 will be greater than 0. So that's positive. Now for the second interval, we have x is equal to pi. And this will be making cosine of pi less than 0. So that's going to be negative. And then third interval, we can set x equal to 7 pi over 4. Then we have cosine 7 pi over 4, and then that's going to be greater than 0, and then that's going to be positive. So now we can label on our intervals. For the first interval, we have positive, then we have negative, then we have positive. And now we have so we include the zeros, which means we include pi over 2 and 3 pi over 2. And for our solution, we want the solutions are going to be negative. So that means we highlight the section interval that is negative, which is that interval. So that means our solution also is inclusive, so that it includes both. It includes the zeros. inclusive of zeros. Yeah, so now we just have pi over 2, 3 pi over 2, and also because this not included means exclusive 2 pi, but remember we didn't have 2 pi as one of our, but 2 pi not a solution, so we don't care about this. It's just like if it was a solution then we would exclude it, but it doesn't matter. It's just like we pay attention to this is exclusive. Okay, and now yeah, we can go to our next problem. So we have 10. Let's say we have sine of x is gonna be minus root of 2 over 2 is greater than 0, and 0 is gonna be less than or equal to x is gonna be less than 2 pi. Okay, so now we're gonna solve for just x. So we get sine of x is greater than 2 square root of 2 over 2, and then that means x is going to be equal to pi over 4 and 3 pi over 4. So now we can label our intervals on, okay, yeah, we can label our intervals. So we can have our intervals of 0, pi over 4, and we have pi over 4, and we have 3 pi over 4, and then we have 3 pi over 4 over and 2 pi. So now we can mark up our intervals. Pi over 4, or more accurately we can write that pi over 4 is like kind of like over here, and then like 3 pi over 4 I guess is like kind of over here, and then now I guess now you just like plug in values for testing. So you have for the first interval, you have for 1, you have x is going to be equal to pi over 6, and then this will give you sine pi over 6 is going to be less than root 2 over 2. We know that, so that means that it's going to be negative. And then we know that for our second interval we can plug in pi over 2, and now we get sine is equal to 1, but that's going to be greater than, of course, root 2 over 2, so that means that it's positive. And then for our third interval we can write x is equal to pi, and then make sine of pi is going to be less than or equal to root 2 over 2 over is less than root 2 over 2. It's going to be negative. So now we can mark this up as this is going to be on this interval. The graph is like this is going to be like this interval represents graph behavior. That's going to be negative, this is going to be negative, that's going to be positive, that's going to be negative. And then remember that our solution, we want our solution is positive, so that means we just include the positive section. Also remember it is exclusive, so that means that you write these circles here. So now you can write the solution as this: 4 pi over 4, 3 pi over 4. Now great, now we can move on to our next question. Let's say we have tan of x is equal to is going to be less than 0, and 0 less than x 2 pi, and it's already isolated, so now we can do tan of x is equal to 0, and this happens at x is equal to 0, pi, and at 2 pi. So that means we know that x is going to be, but we also know that like specifically tan x is undefined at x is equal to pi over 2 and also 3 pi over 2. So that means therefore our boundary points are going to be also including those points too. So that's going to be 0 pi over 2, pi, 3 pi over 2, and 2 pi. So now we can test our intervals after we draw out our number line. So we have this. Okay. We have like 0 pi over 2. We have pi over 2 to pi. We have pi to 3 pi over 2. And then we have 3 pi over 2 to 2 pi. So now we can split this into 4, I guess. Pi, 3 pi over 2, pi over 2. Now let's test some points. But we also know that in quarter 1, like in general, tangent is going to be positive. So that's going to mean positive. And we also know that in quarter 2, just like think of this rule SACT for which positivity like that function is. So we know that in quarter 2, then like also tan is going to be negative. And quarter 3, we know that tan is going to be positive. And then we know that in quarter 4, tan is going to be negative. So now we can mark those onto here. So we're going to have positive, negative, positive, negative. So now we choose intervals. But for our solution, we know our solution is negative. And also it is exclusive. That's exclusive. So therefore we can write our final solution as pi over 2 to pi union of 3 pi over 2 pi. Great. So like I'm gonna box that up. Hooray. So now let's do one last problem. We're gonna do cosine. Okay, so this is question 12. So we're gonna have cosine of x minus 1/2 less than or equal to 0 on the interval of 0 less than or equal to x is less than 2 pi. So now we know we can move this as cosine x is less than or equal to 1/2. So now we can solve this equation. X is gonna be equal to less than or equal to, then we can change that into that. So we know that cosine of x is giving you the exact value of 1/2 at the angle of pi over 3 and also at the angle of 5 pi over 3, which is again 300 degrees. So yeah, so we're like, when you to like quickly like draw this out, like just think of the fact that like 1/2 is like right here, right? And then like this would be like the graph right here, and then this would be 30 degrees, that would be 300 degrees, and then at this degree is like where you get the value of 1/2. So that means that like that's pi. Oh, sorry, I meant to write 60 and 5 pi over 3. 6, 5. Yeah, oh yeah, okay, yeah, I thought I messed that up for a second. Wait, yeah. Okay, that's actually like a little bit, okay, I kind of like drew that a little weird. Let me move that down a little bit. Hold on. Okay, this is like a better illustration of what that looks like. So as you can see, like the x value is gonna be, this means like the x values can be there. So as you can see, that's like 5 pi over 3, which is y. That's the angle. And then this is that's the exact value. Yeah, just so you like really understand it. Okay, so now we can draw our interval. So we kind of ran out of space, but it's okay. So Okay, now we're like really running out of space. Hold on. Let me just put this here then. Okay, so now we can write 0 pi over 3. And then we can write pi over 3 to 5 pi over 3. And then we can write 5 pi over 3 to 2 pi. Okay, now we can test our intervals. So to test, now we can write first interval we can do x is equal to pi over 6, and then we get cosine of pi over 6 is going to be greater than 1/2. It's going to be positive. And then we have x is equal to pi, which makes cosine of pi is going to be less than 1/2, and that's going to be negative. And then for the third interval we have x is equal to 11 pi over 6, and then that means cosine of 11 pi over 6, that's going to be greater than 1/2. That's going to be positive. So now you can just label on here, it doesn't even matter, pi over 3, these are kind of arbitrary. It's not supposed to be arbitrary, but I don't. Positive, that's going to be negative, and that's going to be positive. Now we want our solution is negative, and it is inclusive of boundaries.